Hey guys, today we're looking at correlation and correlation coefficient. First, let's talk about correlation. Correlation is a relationship between two variables. So we're just looking at two different things and we want to see what is the relationship between them. Or we're going to try to make an experiment to test what's the relationship between them. So for example, we have height versus shoe size. This could be one example. We can compare, do taller people have bigger shoes? Do smaller people have shorter shoes? Or is it the opposite? We can look at height versus how good you are in basketball. Is your height, if you're taller, are you better at making basketball shots? Or is that true if you're shorter? We can look at grades versus study time. Do people who study more get better grades? Or does it not really matter how much you study? We can look at speed versus age. Are you faster if you are younger? Or maybe it really doesn't matter. We can take a look at those things. So, we gather our information, we put it on a scatter plot, and we can take a look at this. Here we have a perfect line. All our dots creates a perfect line. So what this is an example of is a perfect positive correlation. What does that mean? So when we look at correlations, we want to test how strong they are. And we test it by using a number that's called the correlation coefficient. This measures how strong a relationship is between the two variables that we're looking at. So the correlation coefficient is represented by R, and it's a number between 0 and 1. For at least when it's positive, it's between 0 and 1. So the strongest relationship is when it's equal to 1, and the weakest relationship is when it's equal to 0. So since this is a perfect positive correlation, it creates a perfect straight line. It's a strong correlation. It's a perfectly strong correlation at r equals 1. Here we have an example where the dots are a little more scattered, but it's still really close to a straight line. This would be a strong correlation, so the number will be close to 1. So it could be 0.97, 0.95. These are some examples. And tomorrow we'll actually look how to exactly determine the correlation coefficient, but today we're just going to make some estimates. Here we have a weak positive correlation, so this number, it's still showing a positive correlation, but it's not strong, so it's going to be a lot closer to 0. So for example, this could be r equals 0.10, or maybe r equals 0.20. These numbers are lower and closer to 0, so these are weaker positive correlations. Now let's take a look at another example. So we have a example here of negative correlations. So here we see the lines going downward. If we have a perfect straight line like this, if we have a perfect straight line, all our points line up on that line, that's what we call a perfect negative correlation. Now it's negative because it's going downward. So remember when we had the perfect positive correlation and equal to 1? A perfect negative correlation will have a correlation coefficient equal to negative 1. Now again, if the dots are close together, not a perfect line, but really, really close to it, we'll have a strong negative correlation. So this could be r equals negative 0.97 or r equals negative 0.95. We can have a moderate negative correlation. This is somewhere in between. This could be r equals negative 0.5 or negative 0.55. Or a really weak negative correlation. This could be r equals negative 0.25 or r equals negative 0.15. So how close it is to making a straight line is how strong that relationship is. Now, what happens if it doesn't make a straight line like we're seeing here? We just see dots all over the place. What this is saying is that there is no correlation between all the data we put in. So let's say we were measuring shoe size versus your intelligence, and they found all of this. That means that there's no correlation between how big someone's feet are and how smart they are. So this here has no correlation. We're going to say r equals 0. There is no relationship. Now let's take a look at a few examples. Here, if I were to draw a line, I see we're comparing exam scores and number of missed classes. I see the line going downward, and while it's not a perfect straight line, it is kind of close. I'm going to estimate that this here is, I see it's going downward, so it's negative correlation coefficient, and let's say it's 0.80. That's just an estimate, and what would this number indicate? This number indicates there is a strong negative correlation between number of missed classes and exam scores. Let's take a look at another one. Here, I see my data is going upward from left to right. So, and I see if I were to draw a straight line, it would look something like this. And since I see it's going upward, I know it's a positive correlation. The dots are kind of close together, so I'm going to estimate that the strength of this has a correlation coefficient of 0.85. This is just an estimate, and this would also indicate that there's a strong correlation between, or a strong relationship between ice cream sales and temperature. So what it's saying is, typically when the weather is warmer, ice cream sales tend to go up. Now, let's take a look at another one. Here, we have no correlation. All the dots are all over the place. And what this is saying is that there's no correlation between the relationship of internet usage and age. Think about these while you guys are working on your next questions. And tomorrow, again, we're going to look at how we can directly calculate the correlation coefficient.